5.1 Overview of Machine Learning Algorithms. Welcome to Module 5.1, the crux of our machine learning journey, where algorithms aren't just mathematical incantations but the very spells that animate our data into predictions and insights. Imagine you're sitting in front of your computer, and on the screen is a playground of datasets, each column whispering secrets of patterns and correlations. Now, let's weave these whispers into a symphony of understanding with machine learning algorithms. First off, we have our supervised learning, where algorithms are like diligent students, learning from labeled data. Think of regression analysis, which, contrary to inducing thoughts of high school math misery, is all about finding relationships between variables. It's like knowing that the more you study, input, the better your grades, output, a familiar relationship, right? Then, we move to classification, where we assign categories, for example, emails as spam or not spam. Imagine a digital bouncer deciding who gets into the club. In the unsupervised learning corner, we've got clustering. Picture this. You have a bowl of mixed nuts. Clustering algorithms are those that can group almonds with almonds and peanuts with peanuts without being told what an almond or peanut is. Algorithms like K-means act like savvy party hosts who group guests based on interests without knowing who's who. There's also dimensionality reduction, where we simplify the complex. If our data was a thick novel, dimensionality reduction would give us the cliff notes but still keep the plot intact. This helps us avoid the curse of dimensionality, a fancy term for too much information leading to poor decisions, much like being flustered in a supermarket aisle with too many choices. We also have ensemble methods, not a boy band, but algorithms that combine the strength of multiple models to improve accuracy. Imagine asking a crowd to guess the number of jelly beans in a jar. Collectively, they're more likely to get close to the actual number than one person guessing alone. Then, reinforcement learning is where AI learns through trial and error. Much like us learning to ride a bike, we fall, we get up, and eventually, we're cruising without training wheels. Picture a self-driving car deciding whether to brake or accelerate at a yellow light. That's reinforcement learning in action. But here's the twist. Algorithms are only as good as the data they learn from and the humans who wield them. So, as we venture through these algorithms, we'll be like detectives, examining each clue our data provides, and like artists, we'll interpret the subtle nuances to make our masterpiece. Remember, the goal is not just to know these algorithms by name but to understand their essence, to see the world through the lens of data, and to use these algorithms as tools to unearth the hidden treasures of information. So, brace yourself as we embark on this quest to turn the raw data into refined predictions that can propel businesses, advance scientific research, and even make our daily lives a tad easier. Welcome to the algorithmic alchemy of machine learning.